This is the fourth and temporarily the last of the series of videos on gravity. I'd like to point out that this was a theoretical study that I made, and that all the calculations are based not on any observations I could have made, because I don't have the equipment to carry out astronomical studies, and for the effect of gravity on the Earth's surface is so weak that you really can't measure its performance very well. So I'm using a theoretical study with data obtained from the internet. I think it was from the NASA website. So these are theoretical studies, and also the calculations are based on what information is available. For example, the radius and the mass of the Earth 4.5 billion years ago I've assumed to be the same as it is now, and that might be all right for the Earth, but for the Sun it probably is not true. That 4.5 billion years ago it had the same radius and the same mass. But I use those figures because they're available, and the whole point is to show the principle on which in the way that gravity works, not to give exact numbers. Remember, we in earlier videos we said that the moon was ejected from the Earth, and here are some numbers I want to show you for the moon and then for the planets when they, assuming they were ejected from the sun. The moon, let's see if we can get that on the screen. The moon's initial velocity when it left the Earth, I calculate to be 24,894 miles per hour. Now, I have been using the number 24,900 miles per hour, but this number is more precise because we're going to see some very, very close numbers, and I have to give more precise numbers in order to show those differences. In this case, 24,900 is close enough. The escape velocity is 25,000. That's only 100 miles an hour difference between the moon's velocity and the escape velocity from the Earth. So if it had gone 100 miles an hour or so faster, it would have kept going and not gone into orbit. The initial period for the first elliptical orbit I calculate as 5 days. Now, of course, it is, as we see below, 27.3 days, and the orbital velocity is 3,683 miles per hour. That's the figures I received. Incidentally, in the previous video, I mispronounced one of the variables. I said it was the Earth's radius, I think, when in fact it was the moon's circular orbit radius. So those are some interesting numbers. But now let's look at some planets. Now, these numbers are really quite spectacular. I calculate that the nearest planet to the Sun, Mercury, left the Sun at 1.377 million miles per hour. Venus, just a couple of thousand miles per hour faster. The Earth a little faster, and so on, all the way to Pluto, which is 1.381. Notice something. These numbers are close together. I'll get them right in a minute. Look, Pluto 12 miles per hour faster than Neptune, and it went over 1 billion miles further out, 12 miles faster. That's most incredible. The Sun's escape velocity now I calculate to be 1.381405 miles per hour, and notice that is not much, 41 miles an hour faster than Pluto's initial velocity. So there's not a very large window at all. There could be planets further out than Pluto that are still in the solar system. There's like 40 miles an hour gap, and we see only that 12 miles an hour gap between Neptune and Pluto. So these are so close together. The window of opportunity to go into orbit is about 0.5% of the velocity, which suggests that there are many thousands of planets may have been ejected from the moon, and those that went over the escape velocity or at the escape velocity would have kept going into other solar systems, and those that went below the velocity of Mercury would have crashed back into the sun. I'll discuss the reason why these planets did not go back into the sun. I did mention it briefly earlier. It's because the orbits start as very narrow ellipses and turn into circles, but that's a whole subject on its own. The next thing I want to show you is, if I can separate this sheet, is the period. Remember I said the moon had a 5-day cycle initially. The planets were as follows. Get them on the screen. Mercury now is 88 days. It initially was 14. Pluto was initially 1,391, just over 1,000 days period. It's now 90,000 days. So there's a very large increase. Those planets that went further out lost much more of their kinetic energy. It almost entirely became potential energy. If anything, it goes out of the escape velocity and keeps going. It eventually loses all of its velocity, and its energy becomes entirely potential energy. That occurs at virtual infinite distance for an escape velocity. Well, that's enough for now. There'll be in other videos, but they may be a little while in arriving. This is the end of my discussion of gravity as such, and I hope you'll look at all the videos and put a comment on there if you find something wrong with my logic. My name is Raymond Davis, and I thank you for watching these videos, which I've enjoyed making. Thank you.